All right, good afternoon, everybody. Great to have a couple of you here today for this general Q&A session. I thought I'll super briefly start off with an outline of what's been going on in the semester so far. So obviously in week one, we've had a general introduction to SPSE, Certified Software Engineering. Then there was an important, in my opinion, very important lecture on working with stochastic algorithms. Those of you who have started to implement some parts for assignment 2 might have noticed that well, many algorithms are stochastic. They are randomized. They rely on random decisions because a priori we do not know where do the best solutions sit. So we need to explore the spaces, and for this we need methods. We need processes in place that allow us to make informed decisions based on well, systematic experimental plans. So this was part of week 2. Then in week 3, we had a combinatorial interaction testing lecture, as well as a one on genetic improvement of software. This is one where typically we target source code, but we can also target components of source code, like the magic numbers that we have targeted here in the deep parameter optimization on Android phones lecture last week. This week so far, we've had a feedback session on Monday, and today we have this general Q&A session. Also, to briefly let you know that so far, many of you have been doing very well in the course. Maybe the last quiz was actually, Sebastian's quiz was actually very simple. Many of you are doing really well, answering on average, let's say with an 85 or so, 80 to 85. We can also see that you all continue to interact with the course content. So you're posting regularly, or well, you're clicking around, you're looking at content, and that's good. Stay engaged with the content. This is a good way of just memorizing more, learning more, and then later on, either later in the course or later, once you work in companies, there's a higher chance for you to remember certain concepts that we've covered here, or even if it's just processes. So as I said, today, we have a general Q&A session. This can be about, for example, the current assignment. It can be about well, if somebody has questions about his or her video or report, we can talk about this as well. We have Viet in the audience. So he's the one marking your assignment 1. He will start in the next couple of days. We're just waiting for some late submissions due to illness. Yes, and then he'll go ahead. And this way you get feedback as soon as possible from us through him as well. So that's me talking now for a little while. Who has questions? And if so, yeah, so just go ahead, unmute yourself or leave the questions in the chat. Not all at once, please. Let me very briefly start with an administrative issue that some of you have encountered. I see currently, I believe it's 4 students in this Zoom call. Do all 4 of you have a group to work in? Or is somebody who is still looking for a group? Zhenghao, I might have come across your name. So let's see. Yeah, Zhenghao. I hope, Zhenghao, you've been able to get in touch with some of the others. It's near Joshua, Chuyang. Currently organizing. Good, thank you. Of course, while you're organizing it, and I believe I've mentioned this briefly in one email, you can already go ahead and read the assignment, put maybe half an hour aside. The assignment might initially look very complex, but it isn't. Of course, you and your team will have to put in some time, make an effort in order to get a good mark in the end. But also keep in mind that this, well, you have about 1 month to work on this project. Yes, about 1 month. Much of this assignment sheet actually consists of, well, help of comments from our sides, clarifications. Yeah. This assignment has also grown a little bit, and we've refined certain aspects so that ideally many of you will or can make progress very quickly. As always, as soon as you do not understand something, or something is unclear and you and your group cannot sort it out, ask in the discussions forum. It's for us the only way to maybe clarify something that is ambiguous before you submit it. If you submit it and you weren't entirely sure about how to interpret something, then you only get the feedback through the mark. If you let us know beforehand, we have an opportunity to refine a particular aspect for everybody in the class. Well, it's good that there don't seem to be any pressing questions. Can I just get a brief show of hands? You can use the Zoom hand function if you want to. Who has already had a look at assignment 2? Don't worry, we're not recording the hands, so I'm not keeping track of this. Vinci has looked at it. Good. Zhenghao, I've seen your questions, so we'll go through them soon. Okay, Vinci even got for assignment 2 some of the code to work. That's very good. Are there any other questions or comments regarding assignment 2 for now? I don't know. If not, then we can briefly talk about assignment 1. So Vinci, of course, if you happen to have any questions about assignment 2, just go ahead and type them in the chat. We won't forget about the chat window here. So Zhenghao, you said you have some questions about problem representation. Maybe this should be called solution representation. There's a chance that for us, because we work with these, well, in this domain all the time, that we might be sometimes calling something slightly differently. So in case it's called a problem representation, technically this is something else. A solution is represented in a particular way. For example, you might remember from the one of the first lectures, the test case prioritization. There, a test suite, even though a test suite consists of, let us say, 1,000 Java unit tests, effectively it's represented for us so that we can search over different solutions as a permutation of numbers. So we have unit test 1, unit test 2, unit test 3, unit test 4, and so on up to unit test 1,000. A solution now can consist of simply the numbers in this sequence 1, 2, 3, 4, 5 up to 1,000, or it might be 99, 42, 3, 13, 512, and so on up to until we have 1,000 numbers together. So it can be any permutation. So a solution in this case is represented as a permutation of numbers from 1 to 1,000. You said you were a bit confused. Would you like to maybe type, or you can unmute yourself as well and describe what confused you? Okay, there's text. Good. Answer that. How can I answer that? What is the problem representation? Exactly. So this is a. How would you answer this? So how is the problem represented? How is the solution represented? Or how is it, given a problem that you have, how do you represent something within that problem? Well, technically for the test case prioritization, I'll just keep coming back to this because it's part of the lecture slides. You can say you take it as a permutation of the 1000 unit tests, whether you work with now the unit tests in, so you would have maybe an array of objects, or you simply have an array of integers, both would work. Now you're referring, okay, to this particular part of this question, of this exercise. So E1 to En. So you have n equations, and you need to select some of these, or one of them, that has the best prediction capability. Okay. What do the others think before there's a chance that I might be dragging this conversation too much into one particular direction or another? How do you represent this? Let me briefly get the assignment up. So I hope I'm sharing the right screen. Not assignment 2. Sorry. Anyone has an idea? Yuncheng, Vinci, Zhongzi, well, technically Viet as well. I'll just give everybody a couple of seconds, just in case he or she is typing. Nobody at the moment. All right, let's see to which extent we can pull this apart. Actually, please excuse me, I need to briefly check something in the background. I will tell you in a moment what I need to check. No, I'm not looking up an old assignment to find out what others have answered, but we might currently have a tricky situation with somebody who has maybe an extension on assignment 1. I know, nobody. Good. Good. Let's see. Let's talk about different components here. The goal is to estimate the software development effort. And we predict this effort in terms of person hours invested, money, or software size. So these might be the different objectives. Maybe you want to be, well, but what's an objective here? Actually, we are not trying to maximize or minimize the number of hours. We're trying to estimate it, right? So where was it? Where was the sentence with the real world? So that we have real world data, where we might have some text or some collections, some spreadsheets that say, for this particular project, we've had the following people working on it. 13 features had to be implemented. These features had different characteristics and so on. And this in the end translated to, let's say, 1,000 person hours. Now, in terms of prediction or effort estimation, an equation would take this information on the scenario as input, and then predict, for example, whether 1,000, or then output a number. If this number happens to be 999 person hours, then the prediction is obviously very accurate, because it's just one, well, in my opinion at least, because it's just 1 hour off from the actual 1,000. Maybe there was a second scenario where, let's say, maybe the team was a lot bigger, more features had to be implemented, maybe with different characteristics, and the overall effort was 10,000 person hours. Now, if we have one equation that takes this as input and predicts again, let me say 9,999 person hours, potentially this is a really, really accurate prediction. But if the prediction, if the formula says we have the prediction is 1,000, not 10,000 person hours, then we are a factor of 10 off. So how do we predict for prediction problems? How can we assess the quality? Let's say we have 10 data, also 10 scenarios with various person hours. The same could also apply to money or software size, but let's just focus on person hours. So scenario 1, then let me just make it simple. Scenario 1, 10 person hours. Scenario 2, 100 person hours. Scenario 3, 1,000 person hours. And we have 7 others as well. How can I measure, well, the quality of an estimation? What some people do, for example, for estimation problems, they use at mean squared errors or just mean absolute errors. So for example, let's just, because it's a little easier for me now to talk about it, in the case with 3 scenarios, with where the numbers predicted, so the actual times were 10, 100, and 1,000. If for all cases, I always predict, so my own equation, right? My own equation says I always predict that the effort is 100. Then for scenario 1, when in fact it was just 10, I'm 90 units off. For number 2, I'm perfect. For number 3, I am 900 units off. 900 person hours. So in total, how much am I off? Well, I'm 90 plus 0 plus 900. So that's 990 units off divided by 3 is 330. So that's my mean absolute error. 330 hours I'm on average off with the prediction. Now let's say this was equation 1. Equation 2 might be different. For scenario 2, I might overestimate and say it's 20 instead of 10. For scenario 2, I might also overestimate, and I will just make it very simple for me because it makes it a little easier. It's 110. And for scenario 3, instead of 1,000, I say it's 1,010. Yes, this is a bit contrived, but I'm just trying to make my life at the moment a little easier. So we have a different equation that takes as input the real data and then predicts, for example, here person hours. How far off am I here now with my mean absolute error? Well, obviously for the scenario 1, I'm off by 10. For scenario 2, I'm off by 10. For scenario 3, I'm off by 10. So in total, that's 30 divided by 3, off by 10 units on average, of course. So now I have these two equations. I have one equation, the previous one you might remember, mean absolute error 330 units. Second one, mean absolute error 10 units. Well, I would say that being 10 on average off or wrong by 10 units is a lot better than being on average for these three scenarios now than 330 units. And obviously, so there are different components here to this scenario. We have different ways of measuring the quality. So when you look at regression problems or prediction problems, you can use mean absolute error, mean squared error. There are lots of other ways of assessing how good your prediction accuracy is. In this case here, because probably something like person hours, money, and software size, this is rather continuous, so not discrete. We would not necessarily look at accuracy or recall. If we had just two classes, for example, where we predict, okay, this belongs either to class I or class B, we have different measures or different metrics for this. But here in this case, we would look into, well, measures like, for example, mean absolute error, mean squared error. So maybe some of you picked this up, that even though, yes, person hours is what our equations are trying to optimize, effectively, we are not trying to maximize or minimize person hours, but we are trying to measure, to estimate the software development effort as accurately as possible. And for this, we need a proxy that we can then use in order to measure our the prediction accuracy. We do assume here that there is some real world data in place, and this will guide our learning here, our creation. Oh, our search, sorry. Good. If it's similar to your answer, this is good. Okay, good. I know I've been talking here for a little while, so maybe I went a bit overboard here with all the details. But if you have something along these lines, then yeah, there's a good chance that you get either all 8 points or something or close to 8 points. Of course, this can also be, well, since it's English text, it can sometimes be interpreted a little differently, and we are open to different interpretations as long as they make sense with respect to the content that we've taught in the course so far. All right, are there any other questions? Assignment 1, assignment 2. Well, as I said, for assignment 2, definitely take the time to read everything carefully. Have a look at the slides that are uploaded. Have a look at the slides and the paper that are uploaded. It's all, in our opinion, perfectly understandable. If it's not immediately understandable, read it a second time, discuss with your team members, and then if something is still unclear, please ask on the discussions forum. It is not, and we highlight this here, it is not necessary to understand every single sentence as it's written in the paper. See it maybe, if you want to have some connection to a real world case, see it as a requirement specification from a customer who says, this is what we want, here is an internal technical report, go ahead, implement it, do it better. or reproduce it. Good. And it's good that, for example, Vinci has already gone ahead and managed to get some of the screenshots done in the setup. Or parts of the setup. Good. All right. Well, it's just 1:36. Are there any other questions? Weird. Just in case that you would like to say something about assignment 2 or so, your recommendations, you can of course do this, but it's not mandatory, of course.
Of course. So I just want to say a bit about assignment 1.
Mm-hmm.
So I've been doing some marking, and I noticed some confusion regarding the first exercise, right? So in the first exercise, we have n equations, right?
Yes.
And we are told that these equations are well formed. This means that each equation can provide a specific prediction given an input. That's what well formed means, right?
Yes.
I see that because these equations have fixed parameters, they are not subject to change, right? So I see some students are confused in the sense that the problem asks them not to train these equations further, but rather just choose one of the n solutions, one of the n equations, right? So yeah, I think there is a confusion regarding how much you can tweak these equations. Well, the answer is that these equations are not changeable, right? They are fixed. They produce a fixed predictions on any fixed input. So you cannot train them to make them better. So that is the problem that we have. So yeah, that's just to clear up the confusion regarding the equation.
It is probably something that we need to ever so slightly make a little bit clearer for future iterations. So this is, yes, correct. So this is what we were after. So pick one of the equations that does the best predictions. Fully agree with this. Yes, correct. So we would end up with potentially just a bit string of, well, indicating whether it's a particular method is used or not, a particular equation is used or selected or not. In principle, we could push this a little further and say, maybe consider sets, and then you can have some weighting between the or of the individual equations, but this goes a little bit beyond what we've covered in the course so far. So while it's technically possible to either make predictions just for particular types of for particular instances, depending on characteristics, or to yes, as I said, weight. So have weights attached to the different equations. This is a bit beyond what we were after here.
Oh yeah, that would be. I think that would be make for stronger questions. I think. Wait, something like a linear combination between the n equations, something like that.
Yes, yes, yes. I'll consider it for next time. I think it's maybe, so it's still possible, I think, with respect to what we've covered so far. But regarding linear combinations, this is maybe pushing it a little bit more into the space of the evolutionary computation course. Because we don't focus too much here on algorithmic components.
As for the second assignments, I would suggest that we start early, because the taking a screenshot can take quite a while. So, you know,
yep.
So start early. That's my recommendation.
Mine too, of course. But definitely start early. You have so typically in the teams 3 to 4 students. At some point, you will need yes, need to run the experiments. They do take a while. Some of you might have noticed that I have pushed back the due date of the assignment 2. Where was it? Yeah, it was previously Friday evening. I've pushed this back, I think yesterday or on Monday, to Sunday evening. The disadvantage is that, of course, this encourages you to work over the weekend. The advantage is that because on Wednesday we have the progress presentations by you, where you can share with us, okay, what have you been able to achieve to date, and you get feedback from us. You can still incorporate the feedback up to the submission. Yep. Unfortunately, because of the public holiday here on Monday, we could not have this any earlier, this progress session. So yes, do start early, definitely. Anything else, Yuncheng, Vinci, Zhongzi, Chenghao? Unfortunately, the chat window does not inform us if one of you is typing, so let's just wait maybe another 30 seconds or so. All right, then let's maybe do the following. So it's, well, technically we still have over 1 hour to go, but if there are no other questions, well, let us do the following. I will simply stay here another 4 to 5 minutes. If any of you has any questions over the next 4 or 5 minutes, please go ahead and ask. But I would say that the official part of this Q&A session, well, is over now. So we can conclude this session now officially. As I said, I'll stay here another 3 to 4 minutes, maybe from now on. So feel free to ask whatever comes across your mind with respect to this course. You will have noticed that there are no lectures next week. Well, Monday is a public holiday. I hope you take some time off. There is, well, you do still have to work towards video 1 and report 1, so you do make use of these additional time, of the kind of free time then on Wednesday at least. Good. Chenghao, no problem. Just keep asking questions. The more questions you ask, the more we can clarify and help you and the others. Good. Okay, as I said, I'll stay here another 2 to 3 minutes. If you happen to have questions, just go ahead.
So Marcus, so in order to do this assignment, reading through the research paper that has been provided should suffice, is it? Because
Yes.
I did read through it twice or thrice, but still finding a little clueless. Maybe I'll have to read through it again twice more to picture it all together.
So the research paper should help. The slides help. They are a little bit this says here gentle introduction, so it's a bit faster, maybe a bit high level. In addition, maybe have a look again at the deep parameter optimization lecture, the slides, even though it's not on Android phones, or here the methodology is a little bit different. It still gives you an idea of what we were after, or what they were in this case after. So the tuning of numbers. In this case here, it's not tuning of parameters that are somewhere in the physics calculations, but it's the colors that are changed.
Okay. And also in the home page here, you have mentioned about the helpful document for the assignment, the link, but the one right below the video, the software engineer's guide to yes. When I did try clicking that, it rerouted to a page where we have to give in the institution details, where I couldn't find our university name.
Sure. Okay, interesting. May I ask, are you in Adelaide?
No.
Okay, no problem. There are two ways to get there. You can. Do you know how to set up a VPN connection to Adelaide?
Yeah. Yes. I've already set up.
Okay. There is through this VPN, depending on your laptop or on the software setup that you run, it should be possible to tunnel the internet traffic through this VPN so that it appears that you are on the university network. I'm saying this because I'm now here in the university university network, and I should be able to download this PDF with no problem at all. So I've now downloaded this particular document. When you are in the university network, when you come from the outside, I don't have an easy way of simulating this now. It's good that you have encountered the problem and that you are now telling us about it. Do not pay for these papers. Definitely not. Viet, or maybe for anyone here, have you used the library in the past to access papers? It is possible. I think I'm doing a little bit of guesswork because I haven't done this in a long time. It is, as I said, normally you can somehow select your institution and then you log in via the institution and you end up getting to the paper as well. Critical practical guide. Is this the one? Yes, I have the feeling that the second one here is the paper. Yeah, a shortcut. Oops. Yes. Yes. So I've searched through the library for this article now, and let me see. When I click on it, I think I end up. Let me just see whether I can get to the paper itself. There's no click here. Online. What happens when I go to online? View text library complete. Let me see, where does it bring us? Sign on. Okay, well, I have to log in. This is fine. Okay, good. So we have arrived now at the same paper. Let me just double check the boy. Yes, it's the same paper. It just goes now via the library of the University of Adelaide. And let me just click on the link. I assume there's no surprise here. Okay, good. So it has arrived for me at the same PDF. Yep, that's the one that I was after. Good.
Thank you. I'll try both.
So try the library. So try the VPN. Try, what did I use here? Uni Adelaide /library. Where was this here? And then this has got me through a couple of clicks, then in the end also to the paper.
Thank you.
If you ever cannot find something, well, ask through the forums or send me an email. This should not hold you back. The university pays for this, in particular here, the library actually pays for these subscriptions. So we have to find ways to make this accessible to you, even when you are currently not in Adelaide. So this applies to both you and maybe to some of the others here in the call as well, if you're currently not in Adelaide. Cool. Maybe one more thing. Let me just try this out. Sometimes, because you have to, so paper titles are typically unique in the sense that There were very few cases where two people have written, or two sets of authors have written different papers with the same title. You can typically Google for the title as well. And while in this case, it does not, well, okay, it points me here either at some IEEE host or ACM, but sometimes, for example, researchers upload their papers to platforms like ResearchGate, to Archive, to others. So let's just see whether we can access the paper here for free as well. So ResearchGate is, it's no bad source. If you can find the paper there, that is a critical review. So no, that is not what I wanted to go. This is not the paper itself, critical review, request PDF. It's not quite the same. So it's maybe here, this one. No, it's again the critical review, practical guide. It seems to be indeed a little tricky to find the actual paper online for free. Interesting, good. Yeah, this can definitely happen, that it's only behind a paywall. But okay, good. I know I've been rambling on now for a while. Use the library. It seems to have worked now. If you can't access it, or if you really can't access it, send me an email and we'll sort it out somehow, or post it on the forums and we'll help you this way somehow. Good.
Thank you.
No problems at all. Okay, last chance maybe for other technical questions, administrative questions. Going on. Okay. Then I would say this concludes today's Q&A session. It's good to have that we've had so many questions from you, even though it was just 4 to 5 students here today. Please keep asking questions in the future. Encourage your fellow students to come to these Q&A sessions. I believe we have at least 1, possibly 2 more planned later in the semester. These are simply opportunities for you to ask, to seek clarifications. We do have, as I said, the feedback sessions for the assignments as well, 2 of them. We've put them in place because we want to provide feedback to you. We want to clarify things to you before you make your final submissions then for the assignments. All right, that's it from my side. If nobody else has any other questions or comments, I will close this meeting now. Thanks very much for coming along. And I will upload the recording as soon as I get the link back from Zoom. Have a happy and safe Easter, or at least long weekend. And we'll meet again then after the long break with our sessions then. Cool. All right, take care. Bye-bye.